Hello everyone, welcome to the presentation. Today's project title is Microwave Oven. It is done by me, Utkarsh Lokhande. In this EMERTXE internship, we have learned various topics including these introduction to C, its conditional, loops and operators, then arrays, pointers, functions, strings, storage classes. We also were introduced to embedded systems and microcontrollers, MPLab, IDE, XC and PICSimLab. Also, we were introduced to various peripherals of PIC16 F877A and its interfacing with various peripherals. Initially C language. It was a procedural programming language initially developed by Dennis Ritchie in 1972 at Bell Laboratories of AT&T Labs. It was mainly developed as a system programming language to write the Unix operating system. Its main feature that it was fast, it had a very clean syntax, low level memory access, and it was general purpose and portable. So here is a structure of C program. We can see here it started with a header #include stdio.h, then second line with int main, and then from line 3 to line 6 it is a body. If this code is executed, then we will get a display screen with output of hello world. Now, applications of C programming. C programming language is accepted widely everywhere. Base of every programming language, it is used in operating systems, it is used in embedded systems, it is used in system software, it is used in networking, it is used in database systems, developing applications. It is just the fundamental base for programmers as a C language. Now, embedded systems. An embedded system is a system that has a software embedded into computer hardware. It makes a system dedicated for a variety of applications or specific part of an application, part of a product or part of a larger system. It can be any one of them. An embedded system may be a small independent system or a large combinational system. It is basically a microcontroller based control system used to perform a specific task of operation. In this figure we can see that an embedded computer has both hardware and software. It has user interface and linked to other systems. It takes variables as input, processes them, gives an output variables. In this way, embedded system works. Now, embedded system components: hardware, application software, which is abbreviated as RTOS. So, starting with hardware is basically something which we can touch in normal language. In technical, it is a physically used component that is physically connected with an embedded system. It comprises of microcontroller based integrated circuit, power supply, LCD display, etc. Then the second part comes, which is application software. Application software allows the user to perform varieties of applications to be run on an embedded system by changing the code installed in an embedded system. When these hardware and software are combined, an embedded system is constructed. Now, to interface these two, it is used which is known as RTOS, real-time operating system. It supervises the way an embedded system works. It acts as an interface between hardware and application software, which supervises the application software and provide mechanism to let the processor run on the basis of scheduling for controlling the effect of latencies. In this figure, we can see that RTOS is in the middle of hardware and application software, and it is used as an interface for between them. Now we move to the next part, which is microcontroller and microprocessor. An integrated circuit which is capable of being programmed to perform a specified task are known as microcontrollers and microprocessors. They have design restrictions such as memory size, I/O capabilities, peripheral functions, etc. Also, a microcontroller should be chosen based on application, its performance, price, availability of tools and special capabilities as required. Now after speaking of similarities, we will speak about their differences. So microcontroller is basically all components will be in a single chip, while in a microprocessor all components are assembled separately. Microcontroller is less flexible, while on the other hand microprocessor is more flexible. As in a microprocessor all components are in a single chip, so the design complexity is very less, while all the components are assembled separately. Microprocessor complexity of design is too more as compared to microcontroller. In the figure we can see that ALU, control unit and registers all are in the CPU, which is a microprocessor. All these three units including CPU are in a single chip, while as compared to microcontroller all the others are assembled separately. It has its own pros and its own cons. Now moving on to our main project, which is microwave oven. Microwave oven is used basically to heat the food using microwaves, which is a form of electronic waves. There are several modes in various microwaves. Out of these several modes, we are going to implement 4 modes, which is micro mode, grill mode, convection mode and start mode. Now we will speak of each one of these modes separately. Starting with the micro mode, we can see that this mode is used to cook food in a traditional way. It uses a maximum power of 900 watts. Here the maximum time that we can set for cooking are minutes or 1 hour. Second mode is grill mode. This mode is used to cook meat and bread. It works as the micro mode, but the purpose is to cook meat and bread. Third one is the convection mode. In this mode, user can set the oven to preheat for a particular temperature, and it takes 3 minutes to preheat the oven. After preheating is done, then the user can set time as per the requirement. Now, for this, what we required were MPLab IDE, XC Compiler to compile the source code, and PICSimLab to simulate it. In PICSimLab, we used PIC16F877A, a 16 LCD screen, a tactical switch, MKP and timer to time. See here what is a PICSimLab architecture. We have various components like GPIO, I2C and ADC on one side, where temp sensor and ADC gives input to PIC16F877A, and on the right side there are RS232 LEDs, buzzer, digital keypad, SSDs, matrix keypad, CLCD. Here we can see that PIC16F877A gives a single way output to LEDs and SSDs. Now speaking of its components, CLCD, it stands for Character Liquid Crystal Display. In PICSimLab there are two types of display, 16:2 and 16:4. In our demo we have used 16:4 characters. CLCD is the ASCII characters and some special characters. There are two types of communication modes in it, 4-bit mode and an 8-bit mode as per the memory requirement. Then moving forward we have interrupts. And communication is a communication process set up in a microprocessor or a microcontroller in which an internal or external device requests the MPU or MCU to stop the processing. Interrupt makes sure that the process is stopped at the time it receives the signal to interrupt. As soon as it requests the MPU or MCU to stop, the MPU or MCU acknowledges the request and attends to the request. It goes back the processing where it was got interrupted. In this way, interrupt helps to handle immediate or on the time interactions which are required by the system. Next is MKP, which stands for matrix keypad. It is used when more number of user inputs are required and still want to save some controller VO lines. These keypads are commonly used in telephones, calculators, digital lockers, etc. We can see here in the diagram what is a matrix keypad and how all of them are connected. Moving on, we have ISR, which stands for Interrupt Service Routine. An ISR is a software routine that hardware invokes in response to an interrupt. ISR attends to the request of an interrupting source by clearing the interrupt flag and should save register contents that may be affected by the code in the ISR. It must be terminated with the instruction RETIE, which is RETIE. When an interrupt occurs, the MPU completes the instruction being executed, then it disables global interrupt enable. It places the address from the program counter on the stack. Hence, it is one of the important features and component which is responsible for the proper functioning of the system. It makes sure that the software routine invokes the hardware in response to an interrupt. So we can see the chronology that when an interrupt is fired, it gives its response to ISR, and ISR is the software routine that invokes the hardware to respond to that interrupt. Moving on, we have timers. Timer is an important application in any embedded system, which is a default peripheral which maintains the timing of an operation in sync with a system clock or an external clock. It makes sure that there is some time of sync which user can relate with the system, and system can make sure at the unit of time on how much it must operate. It has many applications such as measuring time, generating delays, latencies, etc. Timer, which is also known as counter, is a software designed to count the time intervals between the events. Resolution, which is also called registered width, it can be 8-bit or 16-bit, etc. Tie, it is referred as the change from one number to the another number. It may be up count or down count. Quantum, which depends on the system clock setting, is a measure of time which is responsible for the tick. Scaling may be pre-scalar or post-scalar. It may be 1:1, 1:8, etc. Moving on, now we will see the peaks of how the simulation will be shown. Here it is a screenshot of how the first page will be shown when the simulation starts. Here we can see there are 4 options. At the micro mode there are 2 options, grill mode 2 options, convention mode 2 options. And now we will see actual demo. So before seeing the actual demo, we will see the MPLab X IDE, which is the open source which we have used to compile the files. We have here various files. First we have main.c file where we have written the code. It initially started where we defined sec main flag, then we written the code static void initial configuration with the function parameters void. Here we can see initial CLCD where we have initiated the CLCD screen. Then we have off the fan DDR, then fan equals to off, where we have assigned the value off to the fan DDR and fan. Then we have initialized timer 2. Then here it is the main pro function. In main function initially we have initiated the configuration, we have called all the initializing functions. Now we have declared the variables. We can see key is an unsigned character key. Unsigned basically means that where it can't have negative values. Then reset flag, if we have to reset the whole system. Then in the while loop we have key equals to read matrix keypad state. While in 1, it means that the loop will carry until there is an interrupt or break. Otherwise it won't break, it won't stop. Now initially, if door equals to open, we have various door equals to open. It means that the if statement will execute if and only if door's value and open's value is same, otherwise not. Same way all these are done. Now if we see, if we insert key equals to 1, micro mode will be initiated. If key equals to 2, which means we want grill mode, then grill mode will be initiated, or convection mode or start mode. For each mode we have given various inputs which we will need, and we can here delay, power, operation flag or reset. We have here various operations. Then we have here switch code, where we make sure that in case a case power on screen, where operation flag contains the value used for switch. Now in this way the source code is done. Along with the source code we have various other codes like main.h, matrix keypad, timers, clcd, clcd.c, main.c, libraries and loadables. Now what we are going to do is basically we will be at main.c and we will build it. Now it's being loaded, loading completed, the parsing is done, and we can see that the build is successful. Now the build is successful. Now we will open the PICSimLab. We will go to file and load the hex file which is built in the MPLab X IDE. We will open it. We can see in the CLCD screen that it is starting on, powering on, microwave oven is shown. We will wait for it. Soon it will start, and we can see that it has started. Initially we have 4 options as we mentioned earlier: micro, grill, convection and start. If we want micro mode, we can click 1 and it will start basically. Okay, the buzzer, it was done, that's why it was done. Now it has started. First power is 900 watts. Then now we have to set the time. So just for our convenience we will keep the timer as 10 seconds. Now we will hash to enter, we will press. Now the timer has started. Can pause it if we want by entering 5. We can timer has been paused at 6. We can it by entering 4. The fan is flowing, cooler is also, temperature is shown. Now we will time till the time becomes 0. Yes, time's up. The area buzzer, and now we will reset it to use another function. We can see that we can use various functions here. After using mode, now we will use the second mode, which is grill. We can also then we can also use convection mode, or if we can reset, we can apply the reset tool also. If now we will directly go to third convection mode, we can set here temperature how much we want. We will set 100. If it is 10 degrees Celsius, if we want to clear it, we will press star. It is cleared. Now we will keep 80 degrees Celsius, and we will the preheating is now started. We can see the preheating will be gone 3 minutes or 180 seconds. If we want to stop it, we can stop it middle, or we can repeat it again. In this way we have completed microwave oven. So thank you everyone for seeing the demo.